An important part of a weak acid strong base titration, which is a very typical sort of titration and certainly applies to buffers since that is making a buffer system, is known as the halfway point. And that means you're halfway done with your titration. Let's have a look right here. You're taking some acetic acid, for example, and you're dripping in some sodium hydroxide. So immediately you get a rise in the pH because you're making sodium acetate, which is a basic salt. And afterwards it goes up slowly because you're continuously making more of that sodium acetate. And then you will get to the point where you've added an equivalent amount of sodium hydroxide to the acetic acid, and you get this giant rise in pH. Halfway up it right there is called the equivalence point and corresponds to a certain number of milliliters. Interestingly, halfway to that equivalence point is an important point, and this gets asked in just about every AP exam. The half equivalence point, also known as the halfway point, is the point at which the pH equals the pKa, and therefore the hydrogen ion concentration, right, 10 to the minus pH, is the hydrogen ion concentration, is the Ka value. So that's how they can determine experimentally the Ka value for a weak acid. And if you understood that, you could see how they'd measure it. If it took 26 mils to get to the equivalence point, I guess it took about 13 mils to get to the half equivalence point. At that point, the pH is the pKa, so let's answer a couple questions for that. What's the hydrogen ion concentration, in other words, H+, at the halfway point for the titration of acetic acid with sodium hydroxide? Well, you couldn't really answer that unless you knew its Ka, but there it is. The concentration of H+ must be that, right? At that point, the pH is the pKa. That must be the pH. We just take 10 to the negative pH to get the Ka, which would be what is known for acetic acid, which is 1.8 times 10 to the minus fifth. What will be the pH at that point? Well, you would have to take the 10 to, I always have trouble with this, the negative log of the H+ concentration, which is that, is the pH. And so you take the negative log of 1.8 times 10 to the minus fifth, and you get the pH, which is about 4.74. which is right around there, 4.74. So you could either calculate it, or you could just take the intercept and find the intercept with the y-axis, and you're done. So, at the halfway point, the pH is the pKa for the titration of a weak acid with a strong base.